This lesson will teach me to apply the Pythagorean theorem and its converse, use the Pythagorean theorem to classify triangles as right, acute, or obtuse. So, Pythagorean theorem and its converse. Believe it or not, it is an if-then statement, even though it doesn't read that way. It says, in a triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So, this basically says, if a triangle is a right triangle, then a squared plus b squared equals c squared. So let me kind of break all of these words down for you. The sum is addition. The squares of the lengths of the legs. The legs are the two sides that make up the 90 degrees. So it's saying the sum of the squares of the legs is equal to the length of the hypotenuse. The hypotenuse is always directly across from the 90-degree angle. The converse of the Pythagorean theorem says if the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. All right, so in layman's terms, if a squared plus b squared equals c squared, then the triangle is a right triangle. The converse is used for when you're given three particular lengths and you don't know whether it is a right triangle. So if you were to take a value, whatever a is, a value, whatever c is, and a value of whatever c is, remembering that c is always going to be the longest, and you plug it into a squared plus b squared plus c squared, if indeed a squared plus b squared is the same, equal to the value of c squared, then you know that your triangle is a right triangle. Pythagorean triple. Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Here are some of the common Pythagorean triples. Some words in here. Whole. Whole numbers are 0, 1, 2, 3, 4. No decimals, no fractions, no negatives. So the fact that it says non-zero whole numbers means that it's just excluding 0. So these are really your counting numbers. If you can take any nice number, counting number, no zeros, no decimals, no fractions, no negatives, and a squared plus b squared equals c squared, and all of these numbers are nice, then it's referred to as a Pythagorean triple. So if you were to take 3 squared plus 4 squared equals 5 squared and add those figures up, it would indeed work, meaning you have a right triangle, and because these are all nice numbers, it's just referred to as a Pythagorean triple. After a while, you'll start recognizing that some of them are used often, and some students end up using them as shortcuts. All right, so here's an example. It says a right triangle, I'm going to go ahead and draw one, has a hypotenuse length of 25 and a leg length of 10. Put the 10 on either leg. Find the length of the third leg. I'm going to do a squared plus b squared equals c squared. Remember, c is always the hypotenuse. A and b can be switched around. So 10 squared plus b squared equals 25 squared. This gives me 100. This gives me, let's see, 625. To get b by itself, I'm going to subtract 100 from each side. B squared equals 525. To undo a square, if you look at your calculator, the x squared button right above it is that square root button, and it's not there by a coincidence, it's there because they're opposites. So to undo a square, you don't divide, you don't subtract, you don't add, you don't do anything like that, you square root. Those cancel, giving you your b. You're going to need your calculator for this one. It's going to give you a decimal. I'm going to ask that you round, and I rounded to the nearest tenth. Is this a Pythagorean triple? No. Does this work? Yes, with a rounded value. Triple meaning, are they all three numbers nice? No, because this one was 22.9. All right, here's one more. It's not in your notes. Please pause the video, see what you get as an answer. All right, take a peek at my answer. So I took 5 squared plus 12 squared equals x squared. This problem is different from the one in your notes because here the hypotenuse is unknown. The one in your notes, the hypotenuse was known. So notice I labeled that value x as the hypotenuse, so I made sure it went in the correct place in my equation. So I did 5 squared plus 12 squared equaled x squared. 5 squared is 25, 12 squared is 144, equals x squared. Notice I'm keeping the equation, so everything's working straight down. 169 equals x squared. I undid the square by square rooting. X equals 13. This one is a Pythagorean triple because all three of those values are nice. So not only is it a right triangle, but those numbers are nice, which most students generally prefer. All right, converse of the Pythagorean theorem. Here are two problems, each of which have 3 sides, and you need to determine if the side lengths actually form a right triangle. So you can draw the triangle if you want to, or you can label them. A squared plus b squared equals c squared. C is always the longest one. You can call these either thing you want to, and if you want to, you could just call them leg, and hypotenuse. Doesn't matter. So 13 squared plus 84 squared, I want to know, does it actually equal 85 squared? So grab your calculators. Most of you can't do these perfect squares in your head, and I can type in 13 squared plus 84 squared, and it's going to tell me 722.5. Now I'm going to type in 85 squared. So are those two things equal? They sure are. So is the triangle that's made up of 13, 84, and 85 actually a right triangle? Yes, it is. All right, try the next one. Looking at it, the 4 is the shortest, so this is going to be a leg. The 6, next shortest. 7 is the longest, meaning that has to be the hypotenuse or that C value. So I'm going to do 4 squared plus 6 squared equals 7 squared. Well, this is 16 plus 36. Does it indeed equal 49? Grab your calculator. I found that, whoops, let me grab mine. Let's see, 16 plus 36 is 52. 52 doesn't equal 49. So do those 3 things actually make a right triangle? Nope. All right, so the next question is, if they don't make a right triangle, then what kind of triangle do they make? We need to be able to figure that out as well. So if something is not a right triangle, it can be either acute or obtuse. So in your notes, it kind of gives you a spot where it says right with a line underneath of it, acute, acute with a line, and obtuse with a line. So under right, we already know that we would take c squared would equal a squared plus b squared. So if indeed those are equal to each other, then it's going to be a right angle, meaning 90 degrees. And I know this looks a little bit backward, and that's why it's referred to as the modified version. So if it's acute, c squared, I'm still going to set up the a squared and b squared. But in an acute, c squared is going to be less than a squared plus b squared. And not less than or equal to, just less than. And think about it for a second. An acute angle is something that's less than 90 degrees, which is why the equation's been turned around a little bit, because this way it actually looks like c squared is less than a squared plus b squared. So this length here, this c squared length, if you took in an acute triangle, c squared would be smaller than the sum of the other two. Think about an obtuse angle. Obtuse, the angle itself, in order to be obtuse, this angle is greater than 90. So I know it looks a little backwards, but by doing that, I can have that c squared is greater than a squared plus b squared. I have students every year who want to reverse it, and that's fine, but you have to make sure that the order of this inequality is going the same way, and here the order of this inequality is going the same way. So let's try a couple. Classify the triangle as either acute, right, or obtuse. The longest still needs to be your C value, and I know it seems backwards, but I'm going to list it first. So the 14, I need to fill that in with a value, and I'm going to fill it in here like an inequality symbol, and I'm going to fill it in a second. So using my calculator, 196, I don't know what symbol is going to go there yet. I'm going to check it. 6 squared is 36, 11 squared is 121. When I add them together, I got 157. So let's see, 196 is greater than 157. Well, that means it's got to be obtuse, because an obtuse angle is greater than a 90 degree. All right, couple problems to try. Classify the triangle as either right, acute, or obtuse. So find the longest side. This one is going to be that C value. And I know it seems strange, but we're going to put it first this time. I'm going to leave this line blank. It's either going to get an equal sign, a less than, or a greater, but I'm going to wait until the numbers kind of pan out until I fill it in. 6 squared plus 11 squared. So this gives me 196. Still don't know. Those two things added up gives me 157. So 196 is greater than 157, meaning that this angle has to be obtuse, because an obtuse angle is larger than a 90 degree angle. Next one, find the longest leg, longest side, and again, we're filling in this pattern. I'm always going to leave this one blank. It's going to get an equals, a greater than, or a less than, but I'm going to wait and see what the numbers pan out to be. So C squared, 5 squared plus 12 squared. Grab your calculator for those of you who can't do this mentally. 169, 25, that's 144. Those two things added together is 169. So 169 is equal to 169. If those two things are equal, then that means that you have a right triangle, not an obtuse or not an acute, because the hypotenuse squared equals the sum of the other two. On the third one, go ahead and pause the video and see what you can do. Here's my answer. I took the longest leg, which was 7, so I put that in the value and the position of the C, a squared plus b squared, and I found out that the C value was less than the a squared and b squared values, meaning that this has to be acute, because in an acute triangle with this angle and this being that given C value, again, that length squared is less than those other two. And if you look at it and just kind of picture it, those two sides will be longer. If you have any questions, let me know in class.